On behalf of ENAPEC, I'm pleased to be here today to present to you an introduction and an overview of ISO 55000 and asset management. ENAPEC has graciously set up this event today, this training session, as pioneers and leaders in asset management in Pakistan. And very pleased to be delivering the session today. I'm going to ask everybody to please keep your microphones muted. We are recording the session and we will make the recording available after the session as well. My name is David Albrice. I am with Asset Insights, an asset management consulting firm. I am an certified asset management assessor through the Institute of Asset Management in the UK and through the Asset Management Council in Australia. I'm going to turn off my video and we're still allowing, we're admitting a few people, and we will now get the session underway. Again, everybody, please keep yourselves muted at all times. Our agenda today is as follows. We are going to look at asset management standards, asset management frameworks, and asset management systems, with a particular focus today on the ISO 55000 standard. We will explore that standard and explain what it is and what is an asset system. Let's begin by asking ourselves, what is asset management? The definition of asset management in ISO 55000 is the coordinated activity of an organization to realize value from its assets. When I first saw this definition, I felt it was unreasonably short, but everything is hiding in that single word value. That word value contains a universe of information. And in our session today, we are going to unpack what is meant by value. And we're going to look at some examples of what the standard means and implies by the use of the term value. It's all about realizing value from our assets. Regardless of the type of organization, whether we are oil and gas, we're manufacturing, airports, it doesn't matter. The concepts and the principles around value are consistent across all sectors of the economy. I'm just having to admit a few people into the meeting. So why do we do asset management? And we're going to come back to this concept of value over the next hour and a half and look at a number of examples of what is meant by that. Why do we do asset management? We want to comply with regulatory requirements. This is an obvious and intuitive understanding everybody has about the value of asset management. Another obvious reason we do asset management is improved financial performance, improved outputs, organizational sustainability, improved efficiencies, informed decision-making, social responsibility, managed risk, enhanced reputation, increased system reliability, knowledge transfer of an aging workforce, and reduced life cycle cost. So there are many good reasons for doing asset management. And there have been studies to demonstrate empirically that organizations have received these many benefits from implementing and maintaining an asset management system in accordance with best practice and industry standards. Asset management has been practiced since time immemorial. It has only been formalized in the last 30 to 40 years. We see on this timeline a high-level overview of the history, if you will, and the evolution of asset management as a discipline. It was in 2014 that the ISO 55001 standard was promulgated. And we're going to be focusing on that today. The ISO 55000 standard, and also more recently in 2018, in addition to the standard 55010. Again, these slides will be made available to you. I will not speak to all the content on every slide because we do have a lot of material we're going to try to cover in the next hour and a half to provide you a good broad landscape around asset management. Again, everybody, please keep your microphones muted. I keep muting people and they keep turning your microphones off. Please keep them off, everybody. In fact, I'm going to now, participants will not be allowed to unmute themselves. So let me set that up. Okay, so how do we do asset management? How do we achieve this value? There are a number of international standards. We have ISO 55000. We're going to be looking at ISO 31000. There's the asset management anatomy, the asset management landscape, the asset management body of knowledge, and the IIMM manual, which is the International Infrastructure Management Manual. So there are a lot of very well developed, published documents that are available for those who are interested to do a deeper dive in understanding asset management. The two that we're going to focus on today are on the left-hand side, the ISO 55000 standard for asset management, and on the right, the ISO 31000 standard for risk management. The ISO 31000 standard, or rather the ISO 55000 standard, was developed again in 2014, and 31 countries around the world participated in the development of that standard. It is the international standard recognized across the world and practiced in many countries around the world. We will look in a few minutes at some examples of where asset management is being practiced. Before we do so, what we see here is a summary of some of the organizations, the different societies and bodies and institutions that have been developed around the world dedicated to the discipline, to the emerging discipline of asset management. We can see a number of organizations in Europe, in North America, South America, Africa, and Australasia. There are also a number of frameworks that have been developed guide the development of an asset management practice within an organization. What we're looking at here is the asset management framework developed by the Institute of Asset Management out of the UK. This particular framework divides asset management into 6 subject areas. And within each of those subject areas, there is an extended list of 39 subjects. So asset management is recognized as a very broad discipline covering a lot of things, from stakeholder engagement to process mapping, decision-making, development of strategy, policy, maintenance, reliability, engineering. Very, very, very broad discipline. The IAM's framework that we see on the screen now is only one framework. There are many others. Another one that we're illustrating right now is the Plan, Do, Check, Act framework, also known as the Deming cycle. And the Plan, Do, Check, Act framework is a very popular framework for development of an asset management system within an organization. So where is asset management being done around the world? Good to start here to see what are people doing in different countries, different regions around the world, and in different sectors of the economy. Before we dive into the specifics of an asset management system, good to see where asset management is currently being practiced. Now, the next few slides are showing us statistics on the number of organizations around the world that have been seeking out certification of their organizations to the ISO 55000 standard. So in the United States, approximately 2% of the worldwide certifications are from American organizations. China represents about 3% currently of the international certifications to the ISO 55000 standard. Asia, excluding China, has certified approximately 7% of the current listing of certified organizations. The Middle East is currently at about 2% of the certifications. Europe is at 13%. We also, if we add to that, the United Kingdom represents 11% of the worldwide certifications, and the Netherlands 16%. So we can see that the distribution of asset management uptake varies quite dramatically around the world. Certain countries, in this case like the UK and Netherlands, represent a very significant portion of the certifications worldwide. But the list continues. We'll look at a few more examples. Australasia, so Australia and New Zealand together represent 17% of the worldwide certifications to the ISO 55000 standard. And Japan currently sits in first position with 18% of the certifications. The summary, if we look at the summary distribution around the world, we can see that Europe is leading the world in terms of adoption of the ISO 55000 standard, followed by Asia and Australia, and Africa and North America and South America. The Americas are trailing far behind. I myself am speaking to you today from Canada, and I can speak for the North American market. While the North American market is lagging behind Europe, Asia, and Australia in terms of certifications, there is a strong drive to align to the international standards. It's very important to distinguish between certifying to the standard and aligning to the international standard. We do see the pursuit of alignment is picking up dramatically around the world. All right, let's move on to our next step. Who is doing asset management? Let's take a look at the different sectors of the economy, primary, secondary, tertiary, and quaternary sectors of the economy that are currently seeking certification to the international standard. Oil and gas currently represents about 2% of the international certifications to the ISO 55000 standard. Gas utilities represent about 5%, manufacturing and pharmaceuticals around 1%, ports and airports 7%, mining approximately 3%, infrastructure 10%, water utilities 22%, and electrical utilities, electrical generation, transmission, and distribution around 23%. So the two sectors that currently have the most uptake and perhaps the most advanced maturity in asset management is electrical at 23% and water at 22%. These numbers have remained pretty consistent over the last few years since the ISO 55000 standard was promulgated and came into effect. Let's turn our attention now to what is ISO 55000. ISO 55000 is one standard within a larger family of standards, and it's a family of management system standards. So ISO 55000 is a standard for the development of an asset management system. And we will look in a few minutes at what is meant by that. Now, there are other management system standards, some that are better known and have been around longer than 55000. For example, we have ISO 9000, which is a quality management system standard. ISO 31000 for risk, ISO 14000 for environmental management, and ISO 41000 for facilities management. There are other standards not listed here, but these are some of the more popular, more commonly known management system standards. ISO 41000 is the most recent addition to the management system family. And it's very closely connected with 55000. It's really about vertical assets. So plants and vertical assets, including buildings and facilities, could be certified as well to 41000. So there's a lot of overlap and synergies between 55000 and 41000. The one key difference is that 55000 is considering all types of assets, whether they're vertical assets like buildings, whether they're linear assets like infrastructure, or whether they're portable assets such as fleet. 55000 is very broad. It does not limit itself to what kind of asset can be considered. In fact, 55000 also contemplates intangible assets, assets such as data, brand, intellectual property, reputation. These are assets of organizations as well. So let's take a look at 55,000. Now, we sometimes hear people referring to ISO 55,000, 55,001, 55,002. The ISO 55,000 family includes 3 documents. 55,000 includes the overview of the standard, the principles, and some definitions. It is more of an administrative document. The primary document is 55,001. When an organization gets certified to the asset management standard, it is being certified to 55,001. 55,001 contains 73 shall statements. The organization shall have a policy. The organization shall have a strategic asset management plan. And these are the mandatory requirements that must be met by the organization in order to demonstrate conformity to the standard and to be certified to the standard. The 55,002 document is an expansion. It contains additional clarifying language to assist in interpreting ISO 55,001. So strictly speaking, 55,001 is the key document, and that's the document for certification. The other 2 documents provide definitions and clarifications around the standard. Let's take a look inside the 55,000. There are 25,000 words contained in ISO 55,000, 55,001, and 55,002. Here we're looking at a word density cloud that are prepared when the standard was first released in 2014. And we can see which words are appearing more prominently. The word plan, the word objectives. Objectives is a very, very pivotal central term in the ISO 55,000 standard. Everything is about making sure that we align to the organization's objectives. And we're going to look at some examples of that in a few minutes. So planning, alignment to organizational objectives, management of information, management of documents are very, very important elements of the international standard. ISO 55,000 is structured into 7 primary chapters. Here is a visual representation of those chapters. The first one is called Context of the Organization. This chapter is all about ensuring that the organization understands the context in which it sits. Who are the stakeholders, externally and internally? What is the culture of the organization? These are some of the elements of this chapter of the international standard. The next chapter deals with leadership. What is leadership committed to asset management? And that commitment is demonstrated through the development of an asset management policy. And that asset management policy contains principles that the organization will follow to adhere to asset management best practices. For example, policy principles will be, our organization will make risk-based decisions. Our organization will consider whole life costs. Our organization will consider different stakeholder requirements. These are some examples of asset management principles that appear in the asset management policy. The next chapter is all around planning, planning for risk and planning for sustainability within the organization. The fourth chapter in the ISO 55,000 standard is around support. It's around building awareness among staff, communication internally and externally, management of information, and management of the competencies of staff within the organization, whether it's maintenance staff, operational staff, etc. The next chapter is operations. This is about planning and control of the different activities within the organization and outsourcing. guidance about how we outsource services and how do we manage the risk of outsourced services. The 6th chapter is called Performance Evaluation. It includes guidance around management reviews, internal audits, and monitoring of assets. And the final chapter, which closes the loop and brings us back again, is on continuous improvement. The continuous improvement chapter of the standard looks at best practices around corrective actions, doing root cause analysis, understanding why things happened, correcting them, and preventing them from happening again. So there is this iterative loop. Well, it's all about continuous improvement, recognizing that organizations are at different levels of maturity. We will look in a moment at how we ascertain the maturity of an organization, where is the organization on its asset management journey, and how do we move the organization along the path to asset management best practice? What is the roadmap? This is another way to look at the chapters in the ISO 55000 standard. While there are 7 chapters, they actually are numbered. They start with number 4 and they extend through to chapter 10. So chapter 4 is actually the context of the organization, and all of the sections are interconnected and they're numbered, as you can see, 4.1 to 4.4, 5.1 to 5.3. And these are referenced, and each one of these sections and subsections has, as I noted earlier, a number of shell statements that need to be satisfied by the organization in order to conform to the standard. So what is an asset management system? We understand that ISO 55000 is a best practice around the development of an asset management system. But what does an asset management system look like? What does it include? An asset management system is defined as the collection of all the processes and all the artifacts that the organization uses to establish its policy and its asset management objectives. Remember, asset management is the coordinated activity of the organization to realize value from its assets. The asset management system is the collection of all the processes and other artifacts, tools, techniques that are used to establish the asset management policy and asset management objectives. Different organizations have developed different asset management systems. The asset management system should be scaled to the size and complexity of the organization. The standard recognizes that smaller organizations will have simpler asset management systems than larger, more sophisticated organizations. So the standard has a significant amount of flexibility built into the standard with respect to the design and configuration of the asset management system. This diagram that we see in front of us now is using the analogy of concrete pillars and concrete slabs to recognize, to represent the different elements of an asset management system. So we'll take a look at these different elements and how they interconnect with one another. They need to support one another. And as we will see in a moment, this particular representation of an asset management system provides the illustration of how our people within our organization use processes applied and leveraged through software supported by data in order to manage our assets. So there's an important connection that needs to be drawn and interdependencies in our asset management system between our assets, our data, our software, our processes, and our people. And over the next hour or so, we're going to look briefly at each one of these different elements of assets of an asset management system. It's important that there's a line of sight, that we understand that our people have an awareness of what they're doing and what needs to be done around the assets, and how we're using our data to understand and make informed decisions about our assets. and how our processes are being supported by our software. So there's a lot of interconnections between these different elements of an asset management system. So let's start with people. The foundation of any asset management system is the people within the organization. And here we're looking at mapping the roles, the responsibilities, the authorities, and the accountabilities of the people within our organization. Our people are our most important asset. People are at the foundation of an asset management system. If we do not have competent, trained people who have an awareness and a motivation to do good asset management, our asset management system will fail. People are at the foundation of the system. Before I go further, I just want to clarify a point. There are a lot of people in the industry who think that an asset management system is software. And you will hear software vendors say, yes, our software is an asset management system. Purchase the software and you will have an asset management system. That is incorrect. Software is a very important component of an asset management system, but software alone cannot be the asset management system for an organization. So we'll hear of a vendor selling enterprise asset management software, EAM systems, but those are just one element of the AMS. As noted, the roles, responsibilities, authorities, and accountabilities, also referred to as the R2A2 framework. Let's move up in the asset management system to the next level, which sits on and rests upon the people and supports the people, is our processes, our flow charts, our decision trees, our work management systems, our business process mapping notations, our RACI charts, which are responsibilities, accountabilities, who's responsible, who's accountable, who's consulted and informed for the different activities within our organization. So these processes and process elements represent the second layer of an asset management system. The next level is our software. And the different types of software that we may have. Computerized maintenance management systems. SCADA, supervisory control and data acquisition systems. DSS, decision support systems. AIP, asset investment prioritization. GIS, geographical information systems. ERP, enterprise resource planning. There are others. Document management systems, financial information systems, human capital management systems. So the HCM for management of our people through our human resources department is another example of an important software system. The next level in the asset management system is data. And here we're looking at 5 of the 7 attributes of good quality data. The data needs to be accurate. The data needs to be complete, valid, unique, and there are other attributes as well for defining what is meant by good data quality. At the end of the day, garbage in, garbage out. It has been said that a lot of organizations are data rich, but information poor. We need to translate our data into decisions. And we do that through our processes, our procedures, and the software applications and the competency of our people. And then finally, we arrive at the top layer, if you will, of our asset management system, where we have our different assets, which would include mechanical, electrical, civil, structural, instrumentation, communications, assets arranged into different disciplines or different process function code classifications. So the management of our assets into different disciplines is really part of the traditional purview of engineering. But asset management extends well beyond engineering. There is the soft side and the hard side to asset management. The hard, more traditional side of asset management is really when we're dealing with these different disciplines. But as a good asset manager, we have to integrate the hard and the soft sciences together. People, management of people, management of systems, management of data. So let's take a look at these different levels in a bit more detail. Let's start at the top now and work our way down through the asset management system, starting with the assets. And an asset-intensive organization will have many thousands or hundreds of thousands of assets, and they will fall into the different disciplines. Simple illustration here of electrical assets. Another example of an electrical. Things like transformers, generators, switchgear, panel boards, motor control centers, etc. Long list. Mechanical assets such as pumps and valves, pipes, etc. Not going to spend too much time in this session listing all the assets. You all know your assets. It's more about the management around the assets that we're focusing on today. There are many principles and techniques around understanding the behavior of assets, the life cycle requirements, life cycle stewardship of our assets. One common best practice is known as the PF interval. Also extended to be the DIPF, design of the asset. We install the asset, that's the I. We reach at some point potential failure, and then ultimately functional failure where we have to replace the asset. The point of potential failure is where we are now able to detect the mechanisms of deterioration taking place within our assets. Now, this PF interval is represented on a degradation curve. We can see a heat map layered into the degradation curve to indicate increasing risk. So the vertical axis is our resistance to failure. Over time, the condition of our asset deteriorates. It reaches the point of potential failure and eventually the point of potential failure, then the point of functional failure over different points in time. And we monitor and track the condition of our asset as it ages over time. And we can see here on the curve the changing risk profile of our asset as it ages. Now, many organizations are on the journey of developing a library of these degradation curves or deterioration curves for all the assets in their asset portfolio. The asset portfolio is the term used in ISO 55000 to mean all the assets that are under our responsibility, that are part of the organization's asset base. Another term used in ISO 55000 is the concept of an asset type, which is a grouping of assets that share some common attributes. For example, electrical assets might be considered an asset type, or the different types of lighting might be an asset type, or the different types of piping, or the different types of valves. So how we set up our different asset types within our asset portfolio is really at the discretion of the organization. So the PF curve, PF interval, one well-recognized industry best practice used extensively in the domain of reliability engineering to monitor and track the performance of our assets. As we reach points of potential failure, we conduct vibration analysis, ultrasonics, infrared thermographic scans, wear debris analysis, oil analysis, ferrography, and various other techniques to help us ascertain the concealed condition of our assets so we can properly manage the risk between this PF interval that we're highlighting on the slide over here. Let's move on to onto the data layer. We're touching on each layer very lightly. This is an introductory session to asset management. It is just a very, very light introduction to some of the various concepts involved in asset management. So data, one of the keystones of data is the development of an appropriate asset hierarchy. I touched on data quality earlier, but also setting up a hierarchy of our assets. Now, some organizations develop these hierarchies going down 9, 10, 11, 12 levels deep, starting off with the organization, and then extending all the way down to the MMIs, the maintenance managed items, typically at the bottom of the hierarchy. So sometimes we'll see an organization with the organization level, then we'll have divisions or departments within the organization, asset classes, facilities. Within the facilities, we'll have systems, subsystems, asset types, and asset components, all the way down to the, as I noted, the maintenance managed items. And every asset in our organization, in our portfolio, whether it's 1,000 assets or 5 million assets, needs to have a home, a unique identifier, and a home in the asset hierarchy. And the asset hierarchy is used to roll up financial analysis, to roll up risk analysis. It's used as a management tool, not just as a record, as a register of what we have, but also to do financial analysis, even and to manage capital planning and work management. Statistics plays a tremendously important role in asset management. The reason statistics are so prevalent is that many asset-intensive organizations do not have evidence-based or empirical condition data on every asset. Many organizations cannot afford to inspect every single valve, every single pump on a regular interval. Therefore, there's extensive reliance on statistics. Doing analysis on the observed life of how old things are when they fail, and doing statistical distributions. Here we can see two simple illustrations of what are called survivor curves, looking at the survival rates of pumps at the top versus valves at the bottom. So we can see the distribution and the dispersion of one pump was replaced when it was 10 years old, but the highest number of pumps were replaced when they were 15 years old. So we can see we have a dispersion, but we have a modal year at 15 years in this conceptual illustration to indicate how organizations can rely on good statistical modeling to do meaningful, robust, age-inferred analysis and age-inferred modeling of the assets. Ultimately, we're doing a hybrid of evidence-based and age-inferred modeling. The software layer of the asset management system is really about how do we use our data on our assets to give us analytics and business intelligence that we can now make informed decisions, whether it's work management data, geographical information data, financial data, etc. And there are so many attributes of information that we're tracking: asset condition, asset criticality, data quality scores, capacity of our assets. In fact, it's recognized in best practice that there are really 3 types of condition that should be modeled with assets. There is the physical condition, which is the purview of engineers, but there's also the functional condition and the demand condition. With some organizations, we may have assets that are in good condition, but they are functionally obsolete. There are situations where technological obsolescence requires us to replace assets because we can no longer find replacement parts. I'm seeing the occasional note in the chat that the audio quality is not good. I'd just like confirmation of other people. Is there a problem with the audio? Am I speaking too softly, or is it the quality of the audio? Just put some notes in the chat. I will try to speak louder if possible to enhance it. Okay, somebody here says it's perfectly fine. Okay, good, thank you. Maybe it's the audio on the receiving end. Okay, good stuff. Okay, thank you for that confirmation, everybody. So the software piece of the asset management system is really about leveraging our data to help us make informed decisions, and recognizing that our data is heavily interconnected, producing a suite of meaningful dashboards. Here we can see some examples of work management dashboards looking at, for example, things like work order status, downtime, percentage reactive maintenance, etc. There are also many different ways organizations set up their KPIs, their key performance indicators. We're looking at trending. What's the trending of our data over time? We may have assets that are in poor condition today, but they were in good condition previously. And what will their condition be in the future? So we need to understand not what is the condition of our assets now, but also where have they been and where are we going? How are we trending? How do we prioritize? How do we rank using either linguistic scales or numerical scales? How do we grade the condition of our assets? Best practice says that we should use a 5-point scale, ranging from very good to very poor. Some organizations are using a 3-point scale. Some organizations, one department may be using a 3-point scale for condition, another department might be using a 5-point scale. So we need to work towards being consistent in how we report on the condition of our assets. And when one department says something's in poor condition, it should mean the same thing as another department. We also need to map and model the correlations between things. As we will see in a moment when we look at risk, we'll be looking at the correlation between the likelihood of something failing and the consequences if it does. So correlation analysis is a very important part of asset management. Looking at the progress, how are we progressing? How are we trending over time? And how is our condition benchmarking? How is one asset class comparing in condition to another asset class? And it continues. Here's an example, as I noted a moment ago, of a probability of failure and a consequence of failure matrix, and we can see the different asset classes distributed across this matrix. So software and data is there to provide us with meaningful insight into our assets so we can make good decisions. Let's move on to processes. Flowcharts, decision trees, and various other mechanisms used to manage our assets. I made a strong point earlier about the importance of people. There's an element of the ISO 55000 standard that's focused on the efforts put into investment in our people, insourcing, in-house modeling, where we focus on hiring the right people, recruiting, onboarding, coaching, training, mentoring, career development, team building, talent retention, and succession planning. This is the focus where we're focusing on investing in our people. On the other hand, there's also the outsourcing model. Some organizations would prefer to outsource as much as possible. The standard does not indicate whether insourcing or outsourcing is the preferred way to go. It's really up to the organization to make that decision. If we are outsourcing, the standard requires us to manage the risk of outsourced services. And if we're outsourcing, we're managing our supply chain, procurement of services, writing specifications, pre-qualifying our service providers, requests for proposal, requests for qualifications, expressions of interest, service level agreements, contract administration, secondments, spares management, warranty management. So whether our organization is focusing more on insourcing, investment in our people, or outsourcing, which is management of the risk of our supply chain, the standard requires us just to apply the necessary best practices. In reality, most organizations are somewhere a hybrid between insourcing and outsourcing. Another element of management of people is this concept of vertical alignment between the different levels of the organization. Unfortunately, sometimes what happens in the boardroom or the C-suite, the leadership team is not aware of what's happening on the front lines of the organization, and vice versa, the frontline staff don't understand the policies from the top management within the organization. So best practice requires us to seek out what's called vertical alignment between the different levels of our organization, and to ensure that our strategic and tactical and operational activities are properly interconnected. So that's the vertical alignment. There's also horizontal alignment. We hear a lot about functional silos, and many organizations are struggling with functional silos, disconnects between the different departments. The planning department, operations department, maintenance department, engineering department don't always communicate very effectively with one another. They speak different languages, and in some cases, unfortunately, they end up defeating one another without intentionally meaning to do so. So here we can see a simple illustration of an organization, and we'll look a little bit more at interconnecting between different departments. Here we're looking at an organization that I worked with where we're looking at the resource loading within the different roles. They have 16 operators, 11 workers, 5 pipe fitters, 3 technicians, 6 foremen, rolling up to supervisors, to superintendents, to managers, and up to the director. So this is just a conceptual illustration of an organization working to find the right capacities within the different roles within the organization. A best practice in the industry is for management of workflow, particularly work management activities, is the IPSACA framework. Identifying work, planning work, scheduling work, executing work, closing out work, and analyzing work. IPSECA or IPSACA. And what we see on the screen in front of us now is a conceptual illustration of the IPSACA framework connected to a RACI framework. RACI stands for, as I noted earlier, responsible, accountable, consulted, and informed. So a simple spreadsheet that lists the roles within the organization: analysts, managers, supervisors, workers, superintendents, safety technicians, etc. And where are they responsible at each stage of this workflow, and who's accountable, who do we consult with, and who do we inform? So simple RACI charts on a good IPSACA workflow can go a long way to helping coordinate across the different departments within the organization. So in some organizations, we see that we all know who's responsible, but there's a lack of agreement on who's actually accountable. Sometimes a RACI chart will help flush out gaps in the accountability within our organization. So for example, identifying work may fall to our board of directors. They're identifying and helping to prioritize work. The planning of the work may fall to a planning department. Analyzing work, once it's done, may come back to the board. Scheduling work within the scheduling and executing work within the maintenance department, and closing it out as well. So we can see an illustration of the IPSECA framework and which departments might play a larger role within those different activities. We can break it down by role. So for example, in this illustration, we have an engineer who's very heavily involved in identifying and planning work, not very involved in scheduling, executing, or closing it out, but they do analysis at the end. So they're very heavy front end and back end loaded, whereas a technician is very involved in execution. So this framework is a very helpful framework for recognizing and separating and providing clarity amongst the different roles within an organization, and to help break down those silos and improve communication across the different groups. In addition to workflows or decision trees, here's an illustration of an example of a decision tree to be used to identify which maintenance practice should be applied to our different assets. So which assets are good candidates for predictive maintenance, for example? Well, if there's a good monitoring technology and we can develop we can monitor the condition, then a PDM approach might be more applicable. But if the asset were to fail and has no impact on health and safety, it won't impact the organization's mission, will not have an economic loss, then we may be able to carry the risk of running that asset to failure. So just a simple illustration. There are many other examples of decision trees, which are just another artifact in part of the process mapping framework. Oh, so this was the illustration of that decision tree. So let's move to financial analysis. Financial analysis cuts across all the different elements or facets or layers of the asset management system. It is pervasive throughout the entire system, just as risk is as well. And we'll turn to risk in a few moments. Risk management, according to ISO, financial management first, and then we'll get to risk. So we'll take a look at understanding how OPEX and CAPEX, operating costs and capital costs, together provide us with our total costs, our total cost of ownership. Sorry, I'm just having to stop to let people into the session. It's causing me to be a little bit disrupted. Apologies for that, folks. So what we're looking at here is an example of a framework for managing operating costs and capital costs. And on the left-hand side in orange, we have examples of operating costs and maintenance costs. And on the right-hand side, some examples of capital costs, what falls into OPEX and CAPEX. So CAPEX obviously would include things like replacement of the assets, providing additional assets, managing obsolescence. I touched on technological obsolescence, but a major driver as well is economic obsolescence, where we replace an asset where there's now a more efficient way to achieve the same result. So maybe more efficient lighting, more efficient boilers, etc. Legal obsolescence, where we are forced to replace an asset from an instruction from an authority having jurisdiction. Ultimately, our financial analysis should culminate in this kind of forecast. We're looking at our 5-point condition scale from very poor to very good, indicating each successive fiscal year, what is the changing condition of our portfolio based on our current funding allocations. So if our funding is inadequate, then our forecast might look something like this. We can see that the amount of the portfolio in very poor condition is increasing, and the quantum of the portfolio in very good condition is decreasing. So this is an unfavorable forecast. What's happening here is our portfolio is drifting from a 2.93 on the condition scale to a 3.92. And this is actual data from a real organization where they were not setting aside sufficient funds. So here we can see side by side 3 different scenarios where we're using our data, our degradation modeling and doing forecasting on the remaining life of our assets, coupling that with our financial data on funding availability and looking at the trending over time, the forecasting. On the left is what we'll call our run to failure scenario. Our organization is drifting into poorer and poorer condition. On the other side, we have an organization where we're gradually improving our portfolio. And here in the middle, we have sort of like a steady state where the portfolio is maintaining a status quo, if you will. It's not getting any worse, but it's not getting any better either. And we can see the trending of the different scores. So this is one method for modeling and forecasting the changing condition of our portfolio over time. A lot of organizations, particularly ones that are early on their asset management maturity, might be relying more heavily on age-based data and making forecasts purely based on the age of the assets. We want to move to, as I noted earlier, evidence-based modeling and also risk-based modeling. Not every asset has the same criticality ranking, and therefore we can use criticality scores to make decisions and help to flatline our projections into a more reasonable funding program. So let's take a look at risk. ISO 31000 identifies 5 key steps in a risk management process. Identifying the risks, analyzing the risks, evaluating them, treating them, and monitoring them. Risk identification is about uncovering the things that can go wrong. Having workshops of subject matter experts and preparing registers of the things that keep people up at night. What keeps our staff up at night? What do they worry about? You know, equipment failures, injuries, and things like that, contamination issues, regulatory non-compliance issues. Risk analysis is where we start to analyze these risks. We do root cause analysis to understand what could be the causes behind those risks. What's the likelihood of them happening and what's the consequences if they do. Risk evaluation is where we start to apply scoring. We actually we're able to rank our risks and give them a risk score. Risk treatment, where we apply maintenance, or we replace assets, train staff, buy critical spares, various mechanisms for treating the risks, and ultimately monitoring the risks and reviewing the program. So let's take a look very briefly at a few examples of risk identification. I mean, we could have problems with a pump failing, overheating, as a simple illustration of a risk identified. It could be caused by a number of different reasons. Every risk will have different root causes. So it's not just identifying the risk, but understanding the root of the risk and also the causal chain behind the risk. Terrorist attacks, explosions, etc., would be another example of a risk that could be identified in a risk register. Pipe leaks, another common example of a risk in a risk register. What causes the leak? Is it failure of the pipe? Is it failure of the connections? Is it the aging of the pipe? Is it the subsoil conditions? And what we want to do when we're analyzing these risks and evaluating them is plot them on a risk exposure matrix. Mentioned earlier the importance of doing correlation analysis, correlating two different variables. And when we correlate, risk is really about correlating the likelihood of something happening against the consequences. The product of the likelihood score, we can see here a score of 1 through 5, likelihood, and the consequences scored on this axis 1 through 5. So any risk that has a high likelihood of occurring and a high impact or a high consequence would fit into this top right-hand quadrant. And on the opposite end would have those risks that are low likelihood and low consequence. Now, mapping out the consequences and the range of consequences is a very fundamental piece of risk analysis. ISO 55000 places very heavy emphasis on risk analysis and requires organizations to make risk-based decisions. Unfortunately, many organizations have not even developed a risk register or gone as far as analyzing likelihood of things happening and the consequences and deriving as a result risk scores. Because once we've gone through the exercise of doing the risk analysis, we can plot the various risks onto the matrix based on the likelihood score and the consequence score of the different risks. So here we can just see conceptually illustrated those three risks that we showed you a few minutes earlier, and then can make decisions about what needs to be done. Risks that fall into the top right-hand quadrant are what we call the fix now. These are the capital investment risks. Okay, we treat them by spending money, by fixing things and replacing things. The bottom right-hand quadrant, known as the contingency planning quadrant, is often not treated by spending money, but rather by managing the consequences if something happens. Because remember, the likelihood of it happening is low, but the consequences are great. So a major terrorist attack would be very, very significant consequence, but the likelihood of it happening might be low. So for that kind of risk, we would focus on emergency response planning, staff training, and things like that. Whereas these risks, a pipe or a pump failure, would be managed by treating the likelihoods. In other words, replace the equipment before it fails. So final few slides, and then we can open up the session for some questions and to some of the earlier content. Organizations, when they first approach asset management, don't know where to start. The standard says we need to have a policy, we need to have a strategy, we need to have asset management plans, decision criteria, data frameworks, level of service frameworks. And when you read through the standard, it has, as I mentioned earlier, 73 shall statements. You shall have a policy, you shall have plans, you shall have strategies, etc. And it can be quite overwhelming. And it can be difficult to figure out what is that journey to value. How do we get to that value in the beginning of this maze? And what do we need to address along that route in terms of data management, maintenance, risk management, strategy, CapEx, culture, leadership, record keeping, training, planning, stakeholders, funding, communications, budgeting. This is just a very, very small list of the many things we have to manage and pull together in our asset management system in order to realize value in alignment with the best practice. Now, there is no one route to value. The good news is that every organization can develop its own roadmap based on the scale and complexity of the organization. What ISO 55000 says is understand the context of your organization. Understand the structure and culture of your organization. And develop the plan and the roadmap and the strategies based on your organizational situation. And the roadmap will vary for different organizations. There is no one perfect best practice way to go about implementing asset management. As long as you are working towards those different artifacts, the policies, the plans, the strategies, the frameworks, the systems, you are moving and inching your way towards value. And here we can see conceptually illustrated two different organizations that take a different route to value. I've worked with organizations where they start at the top with the big strategic documents and they take a top-down approach. I've worked with organizations where they start at the bottom and they take a bottom-up approach. They develop the detailed maintenance elements and then build those up into the tactical elements and then up into the strategic elements. So that can vary from organization to organization. As part of the best practice, it is recognized that there are different levels of maturity, starting off with level 0, which is an organization that has no awareness of asset management, is what we'll call innocent. They used to call it ignorant, but they changed it to innocent. So innocent, then we move up to awareness, developing, competence, and ultimately excellence. So as you move through the best practice and start to implement different elements of best practice, you slowly move along the maturity spectrum. What organizations do when they embark on asset management for the first time, a formalized approach to asset management, is to conduct what's called a gap analysis. A gap analysis looks at where is our organization today relative to best practice? How far are we from best practice? How many gaps do we have? How big are those gaps? And what's it going to take to close those gaps? Each one of those gaps gets closed through an improvement initiative. Those improvement initiatives get mapped on a roadmap. So if I just go back a few slides to illustrate here. So we'll have a roadmap. Our organization will have a number of improvement initiatives. There'll be milestones along our roadmap journey. For most organizations, alignment to ISO 55000 is about a 5-year journey from the time the organization starts to formally tackle it. It's not something that happens overnight. This is a slow process. So I've reached the end of this very quick introduction to asset management. It was intended to be sort of an hour to an hour and a half. I think I want to again thank ENAPEC for arranging this and coordinating this. I would be pleased to take questions for the next sort of 15 minutes.